Hey folks, Mr. Dell here. We are looking at a problem that has us do some graphing and talking about the shape and finding some information around this shape. So we're looking at a problem that is coming from CPM's Math 2, Integrated Math 2, and this is from section 7.2.3, number 7-113. So it says on graph paper, graph triangle ABC. So I've got A as 3, 0. So this is where A is. I've got B as 2, 7. So 2 up to 7. And C is 6, 4, right? So right here, I'm going to connect my dots, connect my vertices. I have my triangle, okay? So there's my triangle. So it says, what is the most specific name for this triangle? Prove your answer is correct by both slope and side length. So I want to basically see, is there a way for me to find the lengths of each of these sides as well as the angles? Because if I can find the angles, that also gives me some more information about this triangle. For example, I look and I see this angle and I think that might be a 90-degree angle. So we'll be able to do some uh, looking at slope to determine that. And then I look at also these two sides here, these sides here, which would be the legs if that was a right, and I'd say they look to be maybe the same sides, the actual same length. And if that's the case, then it would be an isosceles right triangle, right? And so we can give some more information. So let's determine first of all if this is a right angle. I want to see if that's a right angle. So how do I do that? I find the slope from this point to this point, from those two vertices. So from this is, I'm going to label them A and B. Actually, that's not B, that's C. A, that's C, this is B, right? So I want to know the slope of this, the length AC. So the slope, remember, is rise over run, or change of y over change of x, right? Slope, change of y over change of x is what slope is. So change, meaning the distance, so I'll use a different color here. The change of y would be that vertical distance versus the horizontal distance. So there's 1, 2, 3, 4 here, and 1, 2, 3 there. So my slope of AC is 4 over 3. Okay. The slope of BC, so let's look at that. What would be the slope of BC? Well, the slope of BC, let me get rid of my slope triangle there so that way I can keep talking about the same shape. Slope BC, once again, so from B to C or C to B, that is a change is 3. So the change of y is 3, the change of x is 4. 3 over 4, and in fact, it's also, now it's downhill, it's decreasing, so it's negative 3 over 4. Well, if you remember anything about perpendicular lines, right? Perpendicular lines, I'll put my little note here, perpendicular lines, the slopes, I'll say it this way, slopes of perpendicular, that symbol means perpendicular here, perpendicular lines are negative reciprocals. Okay, so that means they are opposite signs, negative, meaning they're opposite signs. Sure enough, one's positive here, one's negative here. And reciprocal means it's the flip flop, right? You take a fraction, A over B, and its reciprocal would be just to flip the A over B to B over A. So its reciprocal would be B over A, right? So look, I've got 4 over 3 and 3 over 4. So that definitely tells me, based on their two slopes, that I have a 90-degree angle. They're perpendicular. So I can even just say that because these two slopes are the same, I can say that BC is perpendicular to AC. Okay, BC is perpendicular to AC because their slopes are negative reciprocals. All right, so that gives me that. And if that's the case, then I now also want to know, what about these lengths? Can I find BC and AC? Can I find those lengths? Remember, to find the lengths, I'm redraw my triangle here. You draw these little right triangles and you use Pythagorean theorem. because I know this length is 3, this length is 4. So a right triangle that has a leg of 3 and a leg of 4, right, is a special right triangle. Automatically, I know its hypotenuse is 5. Or you could have used Pythagorean theorem if you didn't know that already. 3 squared plus 4 squared equals c squared. So that's 9 plus 16 equals c squared. So 25 equals c squared. So given, there we have it, c is 5. So I know that this length here would be 5. So that AC is 5. And if I do the same thing, draw another right triangle on this side, we also have a 3 and a 4. So that's also a 3, 4, 5. So right away, I can see that BC, so I would say BC is equal to AC, right? Because they both are equal to 5. So I've got some information. I can see that those are equal. I can see that those are parallel, or perpendicular, I mean. So I have an isosceles right triangle. So the name of this, and I'm running out of room because I'm showing you all my work here, the name of this triangle would be an isosceles right triangle. So let me put that over here. Oops, forgot my C in there. Try that again. Isosceles right triangle. It also is known as a 45, 45, 90, isn't it? Because when you have an isosceles right, you know that those angles, that's a 45 degree and that's a 45 degree. So you can also call it a 45, 45, 90. That's also its name. All right. So what is the measure of angle A? Explain how you found your answer. Well, I just got ahead of myself here. Angle A, the measure of angle A is 45 degrees. Why? Because it's an isosceles right triangle. Isosceles right triangles are 45, 45, 90s. And then without using a calculator, use triangle ABC to determine the exact value of tangent of 45. So remember, tangent of an angle, of any angle, is always opposite over adjacent, right? Opposite leg, opposite side over adjacent side. So tangent of 45 degrees, 45 is here. So opposite, which is 5, over adjacent, which is also 5, 5 over 5, which is equal to 1. Okay? All right, there we go.